Hello and welcome back. This is part 3 of a 4-part series on importing and reading through some text data to put it into a class. Now you'll notice we haven't touched the classes yet. We'll get right to that. Hopefully this will be much faster. As someone who comes out of C# natively, I'm a little more comfortable with classes than I am regular expressions. I'll manage both, but I'm a little comfortable with classes. So we'll need a class, obviously, and we'll it's Greg. Alright, everyone say hello to Greg. He's a very nice man. We'll do that. Oops. Oh no, I don't want that either. Greg, come on, man, this is your big debut. You'll need to define your entrance with the init method. And of course we need ourself, who's Greg. We're all Greg today. Everyone say hello to yourself, who's Greg. But then, we'll just call it a hat, and you'll see why. So, what we're going to do real quick is we're going to go self, that's us. We'll need to define a few things for self. What color is our hat? We've got a hat, but what do we know about it? Well, let's go ahead and say equal to whatever hat is going to be. That'll do. No, I don't want that. And, let's give ourselves a method while we're at it. Let's say hi. We'll need ourselves, of course. And I suppose that's all we need for this method. You can put, things into your methods, but for now, that just works. We'll print something. Make it easy on ourselves. Print. Say hi. Actually, this will be a format string. Say hi, I'm Greg. My hat is. And then. What is our hat? Well, what is our hat? We'll return that. This looks about good. Let's go get Greg. We'll make a Greg, and we'll say he's Greg, and his hat is red. That sounds good. And let's say Greg dot say hi. Can a Greg say hi? Oops, sorry. Greg dot say hi is a method. I've asked for the method, not for the method execution. Classic mistake. There we go. He's Greg. His hat is red. Or her. We don't judge here. This is a machine. It does not ascribe to your biological constructs of gender. Cool. That's a class. We've got a lot more work to do than just, a Greg. But it's a start. It's a dip in the toe. Get ready to be dunked in the deep end. Because we'll need a class and we'll call properties. Because, see, that dictionary was nice and all, but maybe I don't have to constantly filter through and see each dot. That does take a lot of work. And what if I want a method tied into this? It's implicitly always going to be there. I'm going to have to define the method every time I want to use it? That's so much work. So, we're gonna send this out for a bit. And we'll say I'd like to define our init method, the classic, and only myself and my list of components for each property. So, we'll go ahead and set self dot components comps. That's good. And then real quick here, in order to make our lives a bit... Oh, do I even need that? Yes, I'll need that. We'll need props dot deque, as it was called to me. I don't know if it's how you pronounce it. Sounds good enough to me. We'll call it a Dairy Queen if we're being silly here. Our Dairy Queen. And that's just a fancy collection. It's like a queue. You know, the line, you put things in, the end, they come out at the start, except I think it's multi-directional and faster. Because it's easy for one property, but if you're running through 50 properties, you might want something a bit faster. So we'll make it to queue. It'll work like a list. So now we want all that stuff back. Except this needs to be indented. Well, thankfully, I can select it all and hit tab once. Thank you, Google Colab. It's so nice. So, real quick, we'll also need to find those coefficient properties, and we'll say C props. And it's going to be the same thing. I'm just going to copy it all, because I'm lazy. I didn't copy from that list. That's okay, it's the same idea. Oh, a dictionary. It's just a dictionary. And a coefficient. Values. For later, we'll insert these one by one, because if you remember... Oh, that's the wrong regex. Of course it is. Oh no! Don't look! My searches! Just kidding. It was just such a regex. Please be in Python again. Oh, I did it all over again. How embarrassing. Well, that's fine. We can look here. You'll notice they're all in a big list. They all came kind of as a big block. That's not easy to read. I can't just split those numbers apart in the regular expression, at least not without some pain. And also, that would confuse the poor list maker. It would know how to make a dictionary where it's got, you know, 1 key and 6 values. That's not how keys work. You can have multiple values. You can have, you know, same value on multiple keys, but not multiple keys. Same, you know what I mean. Keys are unique. If you got more than 1 key, you might have someone breaking into your, entering your place, your door, without you wanting them to. Or am I taking my stuff? I don't know. Maybe in this list. That's a good place. So, and we're gonna say for each key value pair in I was just saying S shorthand. What is that? Well, I don't want to write it molecular weight. That's too much work. I'm very lazy. That's why I'm writing this code. I'm lazy. I want to do this once and never again unless it breaks, in which case then I'll have to do it again, but that's part of coding. So let's shorten it down to molecular weight, MW. So these are just kind of shorthand dictionaries to make our lives a little easier. You didn't miss anything by me putting them in. They weren't there last time. They're there now. They're not that exciting. But we'll need shorthand.items, and that'll give us each key value pair. If you ask for keys, it'd be keys, values, it gives you values. Items, it gives you the key value pair. And I'd like props. Remember, props, it's a dictionary. At the value in this case being the shorthand notation, I'd like to set that equal to the float version, because right now, the regular expression only returns strings. And while we can read that, the computer does not know if that's a number. It's gonna assume no. So let's go ahead and make that a float. And then say S props at key, give us the actual property name, like molecular weight, like about the weight of water. Cool. And yeah, that's there. So that'll give us. Am I missing anything? Yes, of course. We'll get to those coefficients in a bit. That's a whole different mess. But right now, let's just to kind of make it a bit less painful. We're gonna say, ooh, how are we gonna do that? I think I know how. We'll ignore some exist right now. Not important right now. Yes. So we're actually going to go ahead and pull props dot the queue, that funny list, and we're going to use its append method. As a man who's done a lot of work in C# collections, that's a very familiar looking word. Except they use add and like observable collections, but the props, please. And then for pretty, that's just a property in props underscore q 0 please dot keys. Yes, that's that keys I was talking about. That's not the correct one. That one. I would say a value, please, just be honest, and an np dot array classic. And I'd like a bit of list comprehension here, please. We'll say component of name property for each component in props the queue. So what does that mean? It means we're going to go through that list of components, and we're going to go through each property. This property is a list of things we're actually trying to look for. So remember, props.queue.append props. Props in this case is a list of properties. That one. I'm going to append the entire properties, and then for each property in the DQ list and the keys, it'll go ahead and set value. It'll make an array, and it'll say I'd like the component at property at purdy for each component in the component list. Meaning we're basically taking each property of each component, rearranging them so it's stuck. Instead of like we've got water with these properties and ethanol with these properties, it'd say I'd like this property for both. We're kind of flipping it on its head. So if I say dot VP pvap, we'll get to that in a bit, or easier dot MW. I wouldn't have to say like dot watt or dot MW. I can say dot MW and I'll see ethanol has that and water has that. A lot easier. Instead of having to go through each one in the list, it sorts them by their property. That's what that does. And something very fun you can do in Python you can't do in C#, not to my knowledge, and boy, I wish you could, because this basically means writing classes becomes a joke. I'd like to set at her, but I hardly know her. Good thing we're just setting an attribute then. So we'll take a self. It's me. That's this class. It's its own instance. It's instance after all, object based. And I'd like the property. In this case, it is the property. And I'd like to set it to the value, which is that dictionary constructed. I guess it's a list constructed. So it has ethanol this weight, water that weight. Set an attribute named MW equal to that numpy array. That's what we're going for now. Let's see if this works. Now my hope is yes, my expectation is no. Okay, it hasn't broken horribly. So, here's what we're gonna do. We're gonna say, I'm sorry, Greg, you have to go now. We'll come back to you later. His hat is still red. Love that hat. Bye, Greg, you'll be missed. You've served us well in our learning experience. I'd like to make a test. I will say it's equal to an instance of props, and I'd say I'd like water, and let's see if this breaks. Okay, what didn't you like? Why have you taken in the letter W? This is one time I miss things like Visual Studio. I could see where it broke. Why did you hand in a W? Of course, because it tries to read each letter in the list, because technically a string is also a list of characters. Sorry, you're looking at the wrong level. I'd like a one long list that just says water. Things to drink to become hydrated. Water. That's our list. Okay, it didn't scream at us. That's good. Now, let's see what's in test. Let's see if that code worked. Well, that's exciting. We've got an HVAP 0, a molar weight, a tuberculosis, a virtual console, and that accursed W. What is that? It's too powerful for me. The W, please. I wish I knew what that... I think it's actually an omega. What is that W supposed to be? That's its eccentric factor. Well, that's a bit more complicated. Let's just look at that molar weight. Is it weigh about water? Yeah. I'd say that weighs about the same as water. It's probably water. So, as a quick rundown, what we do is, for each item in, we say subject components is components. Prop set to Q is to Q. For each component in components. That's why when we took that singular W in, or just the word water in, it tried to read W, because it tried to read for each item in a string. It can do that, unfortunately. Well, fortunately in some cases, not fortunately here, because it tried to read it as a list of characters. Correct, but not what we wanted. Well, what we did tell it. So, when you make it a list, and the old item is, say, water, it'll say for each component, which is just water, in the component list, which is just water as a list, text is going to be, pull that request. We did that in part 1. If you actually find some data, go ahead and pass it on. And then we'll have a list called sprops. I believe it was part 2. And we'll say a dictionary, and we'll go through the RegEx pattern, the regular expression pattern, and we'll find everything that matches. That was that whole mess. Unfortunately, it's gone. You'll have to trust me, it was there. You can look back in part 2. And take that and pass it through, and then make a dictionary empty props. Make an empty coefficient values for later. I should have commented that one out. It's confusing now. Here, well, look at that. Then for each key value pair in the shorthand, so we don't have to write molecular weight. Also, that space would wreak havoc on set attribute, unless it's smart enough to go up to spaces and underscores. It might be. So we take that and go ahead and say the properties, which is that dictionary. Go ahead and the value, which is the shorthand key. Its item should be equal to the float version, so it's not the string version, the float version of the shorthand properties, which is a dictionary. We've got molecular weight, which is what we're starting with. So molecular weight at key value, which is the longhand version, and boom, it's a list. Then go ahead and add that into the DQ. That way we can kind of run through the component list a whole bunch of times, get the list ready to go. Then for each property again in the DQ list, just the keys, please. The reason being, I think also the queue, you can add multiple keys and it just kind of consolidates them instead of trying to like stick them together. I will say, give me the value. I'd like a numpy array, and an numpy array will be composed of the list comprehension of each component, in which case is just water. And each pretty, and then for each component in the queue, so go ahead and kind of sort through that list, get it all figured out, assign them all to the properties. So instead of being props.water.molecular weight, props.ethanol.molecular weight, it's props.molecular weight water. Kind of a more helpful order, honestly. And so take that and kind of assign it like that, and then give the class an attribute named attached to itself. It'll be the property named pretty, which in this case is like that dot molecular weight, and the value, which is going to be a list, which will be water, comma, that mess, ethanol, comma, that mess, or actually it might be the numbers. That's fine. You should remember what order they're stuck in. But there you go. I know what you're thinking. Does it actually work with two things? I don't believe you only see it with water. Well, we're running a bit long, but we'll give us an ethanol, please. And let's see if that works. And give us a molar weight. Okay. It doesn't exactly have each name attached to it, but that's water's molecular weight, and that's ethanol's. Don't believe me? Show me its components, please. Water, ethanol. Yeah, pretty cool, right? Pretty cool, I'd say. So, in the next part, we'll go ahead and get all those these coefficient values dealt with, and we'll go ahead and look at a method for this class. Sweet vapor pressure.